This is the next in the series of the PWM Experimenters box. I've gotten the automatic control system working quite well. I've tuned up the control system so it's tighter. I've added a temperature sensor to it, so this is just 5 diodes and a heat shrink tubing. I put some hot melt in there to seal it all up. And if you stick this outside, it'll track the outdoor temperature and adjust the panel voltage for you automatically. So these PWM meters, they're about $7. This is what they look like internally. There's a little transistor here. This big fat resistor is the pull-up resistor. Let's look inside the box. So all you really need is this capacitor. There's a FET here. I suggest you put a resistor between the gate and the source. That just ensures that it doesn't go crazy. A FET is it's not a large capacitor, but it's a very high impedance input, and the gate is capacitive. And if you should turn it on a little bit, you can do that with just your finger, with just some static or some other touch. It'll turn on partially, and that puts it into a linear region where it'll heat up a lot. So you don't want to ever do that. I always put a resistor, and I try to get it as close to the FET as possible. So if your wire ever disconnects, and there's some other ways I'm going to explain this, that you can use that to help in the control. But what I've done is I got this extra wire coming out of here. You have the up-down buttons for the duty cycle, and what I've done is I've brought three wires out for that. It's a wire for up and a wire for down and a wire for common. Inside this little tubing here, I have 2 opto isolators, and I did that for a particular reason because a lot of you have all-in-ones, and you have, I do these DC systems, but a lot of you will have an AC system, and you'd like to be able to control it. I mean, in an off-grid situation, once your battery is full, the PV panels operate in the same way. When there's no load on, the voltage will go up, and you'll be able to monitor panel voltage and turn on this system. And I'm going to do this method where you can basically PWM the AC waveform. And this is not the phase control like a light dimmer, where you may have half a cycle or a third or a tenth of a cycle, and it's a very heavy pulse on your inverter, and it drives a lot of them crazy, the control loops. I mean, there's expensive controllers and there's cheap ones, and the cheap ones don't handle spotty loads very well. So what this does is it chops the waveform into little pieces, so your inverter will operate much more normally. But right here we're going to be dealing with a DC system, and like I say, a capacitor bank, this FET, a resistor here, and then you just need a resistor from the PWM creator, and we use an external 12-volt source. I went to a thrift store, and they had a bag of 3 DirecTV 12-volt power supplies. So 3 of them for 99 cents. I figured, what a deal. I'll use one of those because sometimes we'll put this PWM meter to 100%. You may have a 60-volt panel, but at low light level, that'll drag that down to 5 volts or less, and that's not enough to power your whole system. So yeah, just do an external power supply. So let's look into this. Again, we have the PWM module and a 12-volt supply. And you'll have the V plus, V minus. You'll see this. V minus is this outside one, and that's basically common. It's the same as this ground pin right there. I suggest you connect to both of those because these connectors are kind of crappy. If you get a loose wire or something, it can just blow everything up. So having two ground connections gives you some redundancy. So all you really need is a resistor driving this gate. And that can be from 180 to 220 ohms. That softens the transition a little bit. Internally, it's just a transistor connected to common and a 1K pull-up resistor. So if you have a diode, put it across the resistor. That'll make turn on a little faster, because otherwise you'll have a 1K and a 220 ohm in series pulling up the gate, and that'll be a slower time. Putting the diode across means it'll be a faster turn on. This only matters really at high speed. Don't ever run the module up over 300 hertz, because you may get into transitional heating. Transitional heating is when you're operating at high speed. The turn on and turn off take a good portion of the time, and that tends to be a linear portion where it's not fully on, and the FET can heat up. So if your FET's not heating up, you don't have to really worry about it. So it's a module, one resistor, a pull down resistor, and then your capacitor bank. I recommend at least 3 times 470 microfarads. If you have a couple old PC power supplies, you can pick those up at thrift stores for sometimes $2 or $3. They'll have capacitors in them, which are good switching capacitors on the power supply AC section, and you can use those. If you're worried about RF noise, you can add this other extra stuff here. I prefer a resistor and a capacitor. They get rid of noise much better. If you have a really inductive load, if you're driving say an electric heater and it has coiled wires, then you'll want to have a diode. But generally I do soft switching, and the diode is not really needed, and there's can be a little teeny spike, but if you don't see a problem, don't worry about it. So basically you have your hot water heater, your FET, and all the FETs are in this arrangement. You have the gate on the left, the drain, which always goes to common, negative, on the right, and the center is, the source is on the right, the drain is in the center, and that also connects to the tab. If there's a metal tab, that's connected to the drain. So like I say, you can have a switch here, and it's nice to have, right now, you're experimenting around, say you want to change frequency or something. We'll put this in automatic, and you'll see this immediately drives it down. If you have something that needs to be changed in, say, frequency, and you're in this automatic mode, you'll need a switch. But you can also have a switch here. Say you have a solar panel for a very simple system, and you're doing direct connect. You have a resistor. You've set up your heater for about 80% of current, which is probably typical for most solar panels. during most of the sunny part of the day. But in the morning and evening, you want to switch to PWM to match it better. Then this can be, this could be a thermostat, or it could be a relay from a light sensor. And if you open this up, and there's this extra pull up here, you can turn on the FET fully on. So you can have a two-stage system with just this basic simple thing. But that's about it. I mean, there's a lot that you can do with this. Just set this up and start out in the morning. And if you have a power meter attached to it, you can set, like I say, I put this at about 300 hertz. It works good. And then you can ramp up your duty cycle, and you can see where you get your maximum power, and just record what the percentage is, and write down the percentage every half hour throughout the day, and you'll see where the best setting might be for a single position. And you're never going to believe me when I tell you that to have something that really tracks will give you a lot more power. But like I say, we're going to be doing a bunch of experiments with this. It doesn't cost much. In most, if you get an old UPS have good capacitors in them, and you get some high voltage FETs. You can build one of these for almost nothing.